Is it okay? Thank you, Rashmi. Thank you. Hello, everybody. Good afternoon or good evening or good morning, depending on your time zone. My name is Laurent Polidori, and I'm the president of ISPRS Technical Commission 3, Remote Sensing. And on behalf of ISPRS, it is my great pleasure to open this webinar organized by one of our most active working groups dedicated to geospatial environment and health analytics, under the leadership of Professor Murali Krishna Iyyanki, and with the support of the Student Consortium, which is always greatly appreciated. Thank you for that. So it's a pleasure to see many people attending online, and to welcome our two speakers. So Dr. Maria Antonia Brovelli from Italy. Hi, Maria.
Oh.
It's good to see you again. And we will have also Dr. Roshank Srivastav from India. So welcome, and thank you for sharing your experience with us. So I don't want to be long, just thank you to Professor Murali Krishna for this initiative. Once again, congratulations for this very successful webinar series. So I guess you will now introduce our two invited speakers and present the topic of this webinar. So please, the floor is yours.
Yeah, thank you, Dr. Laurent. Greetings to all. Good morning, good afternoon, good evening to all of the people who are attending this event. It is my proud privilege to have some of the eminent people who are working in the area of spatial technology all over from different parts of the world. And with this webinar, the 8th in the cities, which we started last year, basically with the theme on geospatial environment and health analytics. And this is working group 3x9. We are working under the leadership of our president, Dr. Laurent Polidori. And we have two speakers, and I have great pleasure in inviting Dr. Maria Antonia Brovelli, and Professor Dr. Maria Antonia Brovelli will be speaking on the geospatial AI in support of the United Nations Sustainable Development Goals. So before I request her to go for the presentation, I'll just seek her permission to introduce her for about 2-3 minutes time. Dr. Maria Antonia is one of the distinguished academicians and researchers with a Ph.D. in Geodesy and Cartography. She is a professor of GIS, Earth observations, and particularly Copernicus Green Revolution for Sustainable Development at Politecnico di Milano. I think short word is Polimi. Her contribution, if I start reading, she has no time to speak. So let me briefly introduce her to tell one of the most important aspects she has done is she holds her key positions in various international organizations, and she is the vice president of the ISPRS Technical Commission on most important branch of the ISPRS is the Spatial Information Science, and she's also co-chair of the United Nations OpenGIS Initiative and a member of the advisory board of the UN-GGIM Academic Network, Global Geospatial Network, Academic Network. And she was involved in the prestigious ESA, European Space Agency's Advisory Committee of Earth Observations, and her research in geomatics covers diverse areas, various areas, including geodesy, synthetic aperture radar, altimetry, big geodata, GeoAI, one of the emerging areas, and she has Professor Dr. Maria Antonia Brovelli has received awards such as the ISPRS President's Honorary Citation in 2020 and OSGeo in 2015. Here is an eminent person who is, award for her recognition, for her service, for her knowledge. May I request Professor Dr. Maria Antonia Brovelli to give a presentation on geospatial AI in support of the United Nations Sustainable Development Goals. Thank you, Professor. Please go ahead.
Thank you. Thank you so much for inviting me. And so thank you, Professor Murali Krishna. I wanted to thank also Laurent I was not expecting, Laurent, you to be here, so thank you so much. And I want also to thank the Student Consortium, because they are always at service for helping us, the youngest helping the oldest in try to spread our beautiful research. And so thank you, and let's start. So I want to tell you what is my experience with respect to geospatial AI. And obviously, as this is characterizing all the research in my life, I have always in mind that what we want to do is something going toward the sustainability and toward leaving no one behind. And so also in discussing about geospatial AI, we need to have in mind specifically this, which is the basic concept we have to follow in our life. Anyway, the outline of my presentation, I will start telling you what is geospatial AI. I will present you the classification of AI algorithms and models very quickly, machine learning and deep learning. I will enter just a bit into the transformers, telling you what transformers are. I will tell you something about natural language processing and transformers, then switching to vision transformers for Earth observation, and in the end, telling you something about AI for Good, which is an initiative specifically GeoAI I'm creating. Okay, so let's start with the GeoAI. So GeoAI, or Geospatial Artificial Intelligence, refers to the application of artificial intelligence, so machine learning techniques, to analyze, interpret, and extract from geospatial data insights. So in this GeoAI, we have to combine the principle of geographic information systems, remote sensing, geodata science, which are all topics of interest for us, to address spatially driven challenges in various domains as urban planning, environmental monitoring, disaster management, public health, which is one of the topics of this working group, etc. Which are the key components? Key components is, on one side, geospatial and temporal data. Then we have spatial modeling and analysis. And we want to couple it with AI algorithms and models. So let us see very quickly which are the different algorithms and models we can consider. If we start from machine learning, we can distinguish between supervised learning, which uses labeled data, unsupervised learning, which works with unlabeled data. Obviously, we can do different things with these two different technologies. Or the last one is reinforcement learning, which means learning through interaction with the environment and through rewards. This is something that is used typically in robotics, in game AI, but on the other side also in, for instance, path optimization for autonomous vehicles. So something that is very close to what we are doing. If we switch to deep learning is just one part of machine learning, but it is the set of techniques and architecture which are designed for hierarchical learning from large and complex data sets. The key architectures we can consider in deep learning are the feed-forward neural network, which is the basic architecture for structured data. So it's very close from the theoretical point of view to the least square adjustment linear regression. The convolutional neural network, which is specialized for spatial hierarchies, such as, for instance, images, videos, or in general grid structured data. The third one I want to mention is the recurrent neural network, which process data across multiple time steps, making them well adapted for modeling and processing text, speeches, but also time series. So an example, the long short-term memory. And the last one that I want to mention are transformers. These are the last one appearing, and they are advanced models for language, vision, and multimodal tasks. So let us say something more about transformers, as they are the newest one. So what is a transformer? A transformer is a neural network architecture which is based on mechanisms that are called self-attention mechanism. And it is able of modeling relationships between all the elements in a sequence, allowing it to capture global context. In origin, transformers were designed for natural language processing, but then more recently they have been adapted for vision and other modalities due to the scalability and the strong performances of those architectures. What is self-attention? Because probably this is a new word for some of you. Self-attention is a mechanism typical of a neural network that allows each element in a sequence to focus on and weigh the importance of other elements in the same sequence, regardless of their position. Like, for instance, in a sentence is not depending, if you are saying something, you can also change a bit the position of the elements in the sentence, but the sentence has the same meaning. So this self-attention mechanism gives us the possibility, gives to the model the possibility to capture long-range dependency and relationships within the data, enhancing the ability to understand the context and the meaning, particularly in tasks like when we were speaking about sentences, translation, summarization, but also if we switch to images, to the image processing. With respect to this kind of transformers application, we can mention at least, and they are very well known, the natural language processing. And with respect to that, the first one was the BERT, which was introduced by Google in 2018. Then we have a second one introduced by Facebook AI, a name similar to it, just 1 year later. But what became very famous is GPT, because GPT, we had different versions of GPT. You see, starting from 2018, going to the GPT-4 2023. This is a product developed by OpenAI, but we know that it became very, very famous due to the chat GPT. I will tell you something more in the next slide. I want just to conclude this part related to natural language processing, where I'm just mentioning the most famous, but there are much more products like that. The last one I want to mention is Gemini, which was published in 2023, Gemini 5 2.5 Flash, developed by Google DeepMind, and with the same similar characteristic, also better, improved with respect to the initial ones. But what I want to show you is this plot where we immediately understand the importance or the success of this large language model, looking at the number of days which were necessary for passing from 1 million people using the technology to 100 million people using the technology. And you see here the evolution in time of Netflix, of Twitter, Facebook, Spotify, Instagram, And here you see, this is what happened with ChatGPT. So suddenly in really few days, if not few hours, 100 million people started using ChatGPT. And so this is the reason of, or this is the evidence of the success of these technologies. But those large language models are interesting also for us, but there is something more emerging, which is more interesting for us. And specifically, I want to mention the Vision Transformer, VIT, because these are tools specifically designed for processing images. So the idea is similar to the idea we saw before. So a vision transformer partitions an image, an input image, into fixed sides, not overlapping patches, and then linearly embeds each patch into a vector. So transform each patch into a vector, add positional encodings, and then these vectors are feeding are put as food in a standard transformer encoder, which is composed of multi-head self-attention and feedwork layers. And the architecture learn global visual dependency and is able of doing tasks like, for instance, classification and segmentation. The first vision transformer was published by Google Research, was issued by Google Research in 2020, and then many other transformed emerged in the time. You can see here the evolution in time. I'm just mentioning in this list some of them, and I was focusing more on the ones who are open source and where you find also the code available if you want to start putting your hands here. And those are mainly products from the Western side of the world, but we know that there are also some products also open from China, like for instance, this DeepSeek derived from the very well famous DeepSeek that everyone knows. Okay, but what about using these vision transformer models also for Earth observation? Because Earth observation, for speaking about Earth observation, we have that images are paying huge interest in Earth observation. And so for doing that, again, there are many products. I want just to mention this SAT-MEAE, SAT-MEAE, because the interest of this one is based on this concept of masked autoencoder. Masked autoencoder is a self-supervised learning approach with the idea of masking certain parts of the image and training the model to predict the missing parts using the surrounding context. So this is very interesting because this self-supervised learning process helps in leveraging large amount of unlabeled satellite data, which is exactly what we have, without requiring manual annotation or requiring just the minimum manual annotation. So this is very interesting as algorithm, as encoder, and starting from that, some new foundation models, they are called foundation models, or better, geospatial foundation models emerged. The first one I want to mention is this IBM NASA Prithvi Earth observation. The last release is very recent. You see, this is the Prithvi Earth Observation 2.0, was officially published on December 17 in the year 2024. So it has just 5 months. it's a very newborn. Before there was another Prithvi that was released just a bit before. The key attributes of this IBM NASA Prithvi Geospatial Foundation model is that it is pre-trained using exactly the masked autoencoder approach I mentioned before. There are two sizes of this foundation model. One has 300 million parameters, the other one 600 million parameters. It includes both temporal and spatial, so location embeddings, and it is possible to use it for fine-tuning, and this fine-tuning is made easier using the TerraTorch framework. And if we want just to mention the main characteristics, the training data set that was used for training the model are the data from 2014-2023, and specifically it is the harmonized Landsat and Sentinel-2 archive with 6 bands. So totally, the choice of these images was obviously very well conceived. So with a good balance between land cover and ecoregion sampling, and totally 42 million samples across different ecosystem and uses were used for training the model. This is just to give you the idea about the data set distribution that were used for training that model. Okay, but if you want to have more pieces of information about that, you can see that starting from this paper of 2023, and then the last paper in 2024, in the end of the year, they are well presenting everything related to that Geospatial Foundation model that again is available for everyone because it is open. Next one is TerraMind. TerraMind was released just 1 month ago in the Earth Day, and this is we can say that is a sort of generalization of the Prithvi. It is said it is called the any-to-any multimodal model because can generate any data modality, optical, radar, digital elevation model captions from any other. There is a dual scale input representation, so simultaneous processes both pixel level and token level data. And it is pre-trained on TerraMesh, which is a data set composed by 9 aligned Earth observation modality: Sentinel-1, 2, land use, land cover, NDVI, DEM, coordinates, caption, etc. If you want to have more pieces of information, this is the paper where you can find everything you want. And you see that in Hugging Face, you can find the model itself. This is just a graphical representation of what I was saying about this model. But if we want just to summarize which are the performances of the model, here you can see in this summarizing table, this is a list of geospatial foundation models you can consider. On the opposite, the columns represent some experiment with some data provided and the possibility of detecting well the phenomena under studying is represented by these indexes. The closer we are to under the better is. This is the average intersection, mean intersection over union. And you see that depending, there are some models that are better than other in the different experiments. The best one is represented in bold. The second best is represented as underlined. But in the end, if we consider all the possible experiments, you see that TerraMind is performing as the best one at the moment, obviously. Say that this is really something super new, because as you saw, it was issued 1 month ago, but I ask you to challenge yourself, go there and see how it works, because this is representing really the future. Say that I want also to let you know that what we are working as a team of AI for Good. I mean, I'm the creator of this series, which is GeoAI for the AI for Good, which is an initiative of the ITU. ITU is the telecommunication agency of United Nations. And I'm working in organizing events and initiatives within these AI for Good for geospatial information, together with Andrea Manara, which is the geospatial focal point of the International Telecommunication Union, with respect to different initiatives. So there is this global summit in July, you see, from 8 to 11 July in Switzerland. It is an in-person summit. And the 9th of July in the afternoon, we have a workshop related to the role of GeoAI and foundation models in shaping an AI-driven future for all, with many presentations. The workshop will be in person, but I will try to allow also the remote attendance of the workshop. Then we have something more. Something more is represented by all the workshops and webinars we are organizing. Some of them are training in such a way that people can learn how to use these tools I was mentioning before. And if you want to have more pieces of information, there is the QR code that you can scan, search for GeoAI, and find all the webinars and workshops that were organized. This is just an idea. Everything is available if you are interested on YouTube. And you see here, for instance, there was one webinar where the Prithvi 2.0 and TerraTorch was explained. So if you missed the webinar, please search on YouTube, go on the website, search the GeoAI Discovery, and search for the workshop, and you can see them on the YouTube. Last thing that I want to mention are the challenges, because every year we are also proposing some challenges. Like last year, there was one challenge proposed by the University of Padua and my university, Politecnico di Milano, which was about pollution. And so using satellite images, Sentinel-5P images, and data from the ground for monitoring the pollution. Another challenge was proposed by the United Nations Office on Drugs and Crime, and it was related to detect secret, meaning illegal runways in the Amazonas. And 2 other challenges were proposed by the INEGI of Mexico, one related to mapping vegetation and another one related to human settlement detection challenges. This year, during the July meeting, so the AI for Good Summit, we will launch new challenges, 2 or 3. So stay tuned, because you can think of participating to these challenges. And this is the end of my presentation. Sorry if I was a bit long, and thank you for listening to me.
Thank you, Professor Dr. Maria Antonia Brovelli. It's a wonderful presentation, very informative for particularly those people who are working in this part of the world, including the eastern part of the globe, who are working in the area of remote sensing and data analytics with focus on artificial intelligence. I think you were amazing, just brief and focused presentation on the GEOAI, including the NLP and the transformers, is very, very timely, because my present work involved in transformers, how transformers are getting converged into the geospatial data and artificial intelligence to evolve a field with immense potential, because the originally transformers are designed for NLP, and how they are can be used. You think you are just given a hint, and unlike the old one, what you call as the CNN, etc., which capture the image features, the transformers can help a lot. I think this is what you try to convey, and it's extremely useful. And Professor Dr. Maria, shall we ask any questions if they're available, or I also ask them if there is no time, they can post the questions and we can send them any replies when we find time. Is it whatever you say? It's okay.
Thank you. Yeah, if there are questions, they can be asked now if there is time. If not, the people, I believe that Lakshmi of the Student Consortium can collect this question, and I will answer willingly also in a synchronous way.
Yeah, I think we'll just, in view of the limited time, I will ask Lakshmi Tapa to, identify these questions, which are, make a catalog of those questions, and we'll try to get back to those people with your support, Maria, Professor Dr. Maria. Is it okay for you, Professor? Doctor?
Yes, sure.
So again, thank you very much, and please stay back if you know. We enjoy your presence here. When other eminent speaker, Dr. Roshan K. Srivastava, he is a professor at IIT Tirupati, is there, and he's also a project director of the Technology Innovation Hub at IIT Tirupati. Dr. Roshan Srivastava is a leading expert in hydrology and water resources management, and also related to the issues of system dynamics. And he has very much contributed significantly to through research to harness advanced computational, statistical, and the GIS techniques to tackle pressing challenges in specific important point is water scarcity. The whole world is facing different manner the water scarcity, and urban watershed management, and also reservoir operations and climate sources. He holds a PhD from the premier institute of in the India. It is called the IIT Madras, and he also Dr. Srivastava adopts interdisciplinary approaches integrating the tools of machine learning, remote sensing to develop some sort of innovative solutions for critical water and climatic analysis. And Dr. Srivastava has been honored with numerous accolades, including some of these, like I'm just giving a small list. Otherwise, as I told you, I cannot give him any time to speak. But let me briefly tell what are the awards. Prestigious AGU Broker Fellow, Berkner Fellowship, and some sort of MLT ACS Accelerate Fellowship, and National Geospatial Faculty Fellow Award at the 2024 National Geospatial Awards by FOSI at IIT Mumbai. And he, as a project director and of the Technology Innovation Hub at IIT Tirupati, Dr. Srivastava holds a very important position and is taking a lot of initiatives in geospatial and remote sensing technologies, particularly related to the positioning, navigation, and timing technologies. PNT, that's what is briefly it's called, an interdisciplinary research, and he's driving impactful advancements in sustainability and related aspects related to the application of the technology, positioning, as well as navigation and timing technology. So here is our expert, Professor Dr. Roshan K. Srivastava. Please take your time, sir.
Okay, sir. Thank you. Thank you so much, sir. Are you able to hear my voice?
Yeah, I'm able to hear you.
Okay, sir. Thank you for the opportunity. I would just like to share the screen.
Lakshmi, can you share this?
Yeah.
Yes. We
I'm
cannot
sharing.
see the screen yet. Have you started sharing? Have you started?
Yeah, I'm just about to share the screen.
Okay. We haven't seen it yet. Yes, it's coming. Perfect.
Yeah, thank you. I think I'll quickly, there's a lack of time. I think I'll just present comprehensively
You can
what
take
we do.
25 minutes, 30,
Yes, sir.
25, 30 minutes, please.
Sure, 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 sir. Okay, would like to definitely talk about something very unique, what is happening in India about remote sensing and GIS. I'm coming from a technology innovation hub at IIT Tirupati. Uh, what we government of India has done is under the national mission of interdisciplinary cyber physical systems, they have divided the entire CPS into 25 verticals. As you can see on the screen on the left hand side, that you name any technology, I think all the participants should be able to relate to one of the technologies. And the CPS is divided such a way that most of the technologies related to what we think like India is importing right now become self-reliant in future. So it has been divided like this, and each of these technology innovation hubs have been established in primarily in the premium institutes like Indian Institute of Technologies and Indian Institute of Science. And there is one which is established in IIT Tirupati, where I'm coming from, is on positioning and precision technologies. So when I say positioning and precision technologies, it means GIS, remote sensing, GNSS, or any other non-invasive technologies what we use for Earth observation below on the space or on the atmosphere on the terrestrial side. So this is what our technology innovation hub is focusing on. What do we the technology innovation hubs do? I represent all the 25 technology innovation hubs. So the four objectives of the hubs remain the same. The first and the foremost is on the technology development, which is more on focusing on translational research. For example, I think many of the research community has been almost focusing on converting their research into publications. But can we look at beyond that? The whole idea is to make research community to convert their research into an useful products. So translational research and the technology development plays a major objective for us. The second most important objective is also to support, which is every country's backbone today, is the startup ecosystem. And unlike any other incubation cell or incubation or entrepreneurship entities, we do support startups right from idea stage to acceleration stage. The third most important objective is to look at to cater how do we reduce the skill gap required to handle the advanced technologies in CPS. So we have number of schemes to support under human resource development, wherein we provide fellowships to the students across the nation who can work with the startups. Usually, startups have difficulty in finding the manpower and the funding for support for having manpower. So, human resource development funds helps them to kind of identify the regional or a local resources for their product development. And finally, there's a collaborations. In fact, it should read as an international collaborations, wherein the whole idea is not even just to onboard the experts, but also to see if we can identify an IP which we can bring it to India, and then mostly by the research community or startups to kind of work and develop the product in India. So these are the four major objectives of all 25 technology innovation hubs. But in specifically, when I'm talking about IIT Tirupati, we will be focusing in the core area of positioning and precision technologies. And all these 25 technology innovation hubs are registered as a Section 8 company. And what we called our company as IIT Tirupati Navavishkar iHub Foundation. So the domains of interest are like any other technology. If you see GIS, remote sensing, and GNSS, or any non-invasive technologies, we can divide into three major verticals. The first one would come as a capturing technology. So our focus is to look at development of these sensors, like for example, GPS, LiDAR, radar. How do we kind of contribute towards the technology to develop the hardware sector? The second most important component, as the previous speaker, Professor, was speaking about the use of data, and all these sensors, imagery, what we collect today, had to have a data analysis and processing technologies. And GeoAI is no exception today, that everybody would like to kind of use the power of AI. And that is what we do in this second domain, where we would like to kind of use this data to come up with the technologies more related to image processing and data analysis and provide the solutions. Beyond this, today we don't even look at more of a capturing technology. We don't care where this data is coming from. I mean talking in terms of, let's say, the stakeholders, the decision makers. They are not worried about how is this data coming from, which sensors, what kind of a processing goes on the background. It's more about, today we would like to have a user experience, user interface solutions. So one of the other sectors we majorly focus is to how do we kind of integrate the immersive um, navigation systems like AR, VR, various graphical user interfaces can be created, a lot of integrated dashboards. I think geospatial has the most, I mean, it can be having a very variety and various domains for creating these dashboards. What kind of an application centers? I think this is one of the areas where, if you open any, even the sustainable development goals, I think geospatial has to play in every, I mean, 18 of them. And you name any country's burning issues, especially I'm talking in terms of India, where we see agriculture, we can use remote sensing and GIS, urban planning, natural resource management. We also focus on very important areas such as underwater navigation and mapping. In fact, GPS denied environments is one of our key areas where most of the world is trying to focus. In case the GPS is denied, or there's a known accessibility of GPS, the satellite based navigation system, how do we kind of track the things? Disaster management is another area where a lot of remote sensing, GIS, AR, VR has been used currently. Any defense, we have seen number of wars, and then you can see that a lot of GNSS positioning, navigation, timing is being used. And of course, we would like all our cities to be smart. We are also not working on smart cities, but also looking at smart villages, because much of the India's population resides in villages. And we are also trying to see how GIS and remote sensing, or in turn PNT, helps the village, the communities across, supporting their livelihood. As I said, we support a lot of technology development projects. So we do a lot of funding. We have about more than 30 technologies which are coming up in our technology innovation hub. And we have been funding this across the country. We do support various universities, institutes. It's usually done in a consortium mode where startups, industry, and academia come together. But the project is usually given to the research community, wherein they get support from the industry to develop a product. So the whole idea of this funding is not to just produce the publications, but it is to supposed to get the IPs generated out of this, and also um, product which is at least lab demonstratable under lab environments. This is nothing but technology readiness level should be at least 4 or greater than 4. I'll just show you some quick these are some of the institutes in India which have been partnering. As you can see that across the country, there are a number of institutes which have been part of this technology development projects. There are few of these technologies I'm listing over here. Anti-jamming, anti-spoofing of GNSS will be the next big thing, and it plays an important role when we are talking about remote sensing and GIS. So there is one important faculty community which is working from Shastra University, focusing more on the anti-jamming, anti-spoofing. As we also understand that the timing sector is very important. So there's a group of researchers who are working on developing a transportable all-particle trapped ionic atomic clock for PNT. So our idea is not just to look at only the space sector, but also there are a number of other sectors, especially in the finance sector, where these atomic clocks have become very, very important. So so it's all indigenously the research community in India is trying to work on to develop this atomic clocks. There are few projects like for identification of aerial images, small objects for tracking. And there's one interesting with respect to remote sensing, in-house development of hyperspectral camera, which is usually quite expensive when we import, but there's a group of research community from Karunya University, faculty from Karunya University have been working to develop uh, uh, hyperspectral camera, and I think they have been very successful. I have already seen the demonstration, and we are very happy to see that the product has, at least it has reached to a lab environment where they are able to show the hyperspectral camera is working. We also have, I think the projects what I'm showing is mostly related to the navigational aspect, but somewhere or the other, it is also important for us to kind of integrate with the remote sensing. Uh, as this integration of tightly coupled becomes very important, especially when we are under autonomous vehicles. So these are some of the techniques which we are working. Also in combination with the GNSS and remote sensing, the campus mapping, we have assistive system for blind school students where one of the institutes are working to develop this. We also combine 5G and GNSS system to improve navigational and positional drones. So these are few of them. The slides, there are few new projects which are more related to remote sensing. Like for example, we are also trying to develop disaster management tools for the state departments where the flooding often happens in the cities, major cities. So how do the disaster management people quickly can uh, relate it to and then find out some kind of a measures. Startup ecosystem, we have number of schemes where, as I said, like right from an idea stage to an acceleration stage, we do fund. We have almost, as of date now, the numbers what shown in the slides are quite a bit older, but today we have about 36 startups have been fully funded, and most of the startups are in the early stage, but quite a few are there. At least I would say like about 10 startups are in growth stage where they are really trying to develop. And all these startups, 99% of the startups are related to GIS and remote sensing. Other than that, we have a very unique scheme for startups. Usually, what I've been looking at the startups for last 2 to 3 years, there's no problem for them to get the small grants, and there are also VCs available to fund larger uh, amount. But when VCs fund it, there's a issue with the equity, dilution of the ownership, and the grants what they get is a smaller amount, are usually not enough, at least in the case of India I'm talking about. So what we are trying to do is we are trying to get the businesses to the startups directly from various organizations. Usually we get a lot of opportunity to get into large projects, and these large projects are in fact done by our startups. So as of now, today, when I'm talking, we have 200 plus startups registered under Vikas Incubation, and all these startups, in one way or the other, will be benefiting through our businesses, what we get it to their table. We do a lot of human resource development programs, as I said, like for the, especially this is for the startup and research community to find good manpower, right from UG to PG to PhD to postdocs. We do number of internships for the students. We have now created 12 PNT labs across the country. We do training programs, especially GIS. We have something called Vidya GIS. We do right from the schools. I'm in sixth grade onwards. We kind of create the spatial thinking concepts in the children, and it goes right to the executive program. So we have been training the executives, like synthetic aperture radar was the last program what we have done for Survey of India officials. Likewise, we are planning to do some advanced remote sensing techniques for the Andhra Pradesh state government over here. We also try to work with various organizations across the country, like IIT Bombay. There is an group working on FOSSI, which is for an open source. They're very active in GIS and remote sensing, so we work together. There is a geospatial innovation, science and engineering at IIT Bombay again. So we work very closely. We are kind of setting up OGC standards. We are working very closely with OGC to see how we can kind of create an OGC standards environment in the country. We also work very closely with various other organizations. Currently, we are working with Google. There were a couple. Recently, we are also working under one national hackathon for air pollution remote sensing with Google. It has an AirView Plus, so we are trying to create ideathon and hackathon with them. As you can see that number of schools participate over here, but mostly there are engineering students and graduates. So the very wide variety of programs what we do. The most of the pictures what you see is the school uh, uh, from 6th grade to 10th and 11th grade, where we have done number of schools. Now there's a lot of schools coming forward in the country to kind of get exposed to so space technologies. So we are also trying to show them like how do satellites capture these images and what happens after the images available data. How do you capture the data and then put it? So these are all done on the open source QGIS, and we do use QGIS to train all the students across the country. We do a number of, as I said, like UG/PG fellowships. There are both hardware and software contributions from the students across the country. Number of dashboards and web-based tools have been developed. Especially, I'm going to talk about something called Spatial Lens app, which has been developed to just capture the underprivileged businesses across the country, where the students will go capture the location. And so we would like to understand like some of these businesses, mostly underprivileged businesses in India, where are they located? What is the kind of business they do? So a lot of information with a very small app, we have been able to do it. And there are a number of other themes which we work on. So most of the students are very talented, and when they come into the internship, they usually try to kind of develop a very good useful tools, and some of these tools are now in consideration with the state government to use it for their purposes. So very good contributions are done right from the student stage. This is one of the dashboards which we have developed using the imagery. So we have created a 3D model.
Any problem?
We cannot hear him. Maybe internet
Roshan, we are not able to
issues.
hear you. Roshan, we are not able to hear you.
Maybe you can you try
Sir,
to
able to
turn
hear
off
me?
your video?
Yeah.
Maybe if you turn off your video, the bandwidth may get a bit better.
You turn off your video, maybe. Shall I?
Yeah. Yes, sir.
Still, we are not hearing Dr. Rosen. Yeah.
Are you able to hear me now?
Yeah.
Yes.
Yeah, sorry. So I was saying that we do a lot of international workshops, national workshops on very advanced topics, right from computer vision to ground penetrating radar, synthetic aperture radar, digital twins. So number of other agencies, major agencies also combine with us. We are working very closely with, so we do support proprietary and FOSSI, and much of our training for schools and institutes usually are on the open source, and if the industry would like us to train on the proprietary software, so we do have a lot of support from ISRI, Hexagon, and a lot of other institutes across the world who provides us the software support to train the community. So we do also do a lot of stakeholders meeting.
Sorry, Dr. Rosen, your slide is not visible.
Okay.
Have you
Second,
stopped finishing the slides and giving the remarks, or are you still talking about the slides content?
No, I think 1 minute. I'm just sharing my slides.
Okay. Thank you.
I'm done. I'm done.
Thank you. Yes, we can see it now.
Thank you, Dr. Roshan Srivastav, for making what national progress in terms of positioning, navigation, and timing. Are you still continuing, Roshan? Roshan, are you continuing? Your voice is not there is some problem.
Sir, able to hear me?
Now it's okay. But sometimes it's getting blurred.
Yes.
It's okay.
Yes, sir. So this is the last slide. I wanted to produce this last slide. We are working closely. We are also part of this, very fortunate to have this national geospatial policy in December 2022, where the data mapping has been liberalized and a lot of freedom has come in terms of remote sensing and GIS activities in the country. And we are also supporting the number of activities at a national level. One of them is Operation Dronagiri, where the 5 districts across the country have been selected to kind of develop a solution in 3 sectors. So we are working majorly on remote agriculture sector. The second one is on the transportation and infrastructure. The third one is on the skill development. So the whole idea of the Operation Dronagiri is to startups to come and develop using the data sets which have been already available with the government and come up with the solution. So we are expecting by the end of 6 months under Operation Dronagiri in the fast track mode, we should be able to have almost about 30 solutions for the district administrations to be able to implement and scale it for their purpose. And I think with this, we have a number of partners across the country and across the world. And then we are very fortunate that with their support, we are able to kind of, support other institutes and research community in the country. Thank you for your time. Thank you, sir.
Thank you, Roshan, Professor Roshan Srivastav. The very interesting and positive development from the Indian government in terms of developing a technology innovation hub and IIT Tirupati is leading in terms of focus on positioning, navigation, and timing technologies. And Dr. Roshan has given a good number of topics that his hub is handling. Particularly focus is on translation research, because a lot of research is being there, and a lot of even I go to an extent of telling there are many patents that are obtained, but what is the fate of these patents? So this translation research is the catchword, and for conversion of the research, at least beyond TRL4 to a product process development. It could be product development, it could be process development, and IIT Hub under the leadership of Roshan Kumar Srivastava is doing human service. And one of the most important things, as I could see from his presentation, is the what you call as the 3D services of inundation map of urban floods, etc. And that is a very good positive and practical need in the country. And he has also mentioned about one of the other important areas is the for the startups to provide any data required from the Operation Dronagiri, specifically in 3 sectors. I think they are all related to agriculture, transportation, apart from the skill development. So they also have a lot of data. That is what is the most important thing in the need of the academic and research community. And I request the entire community, from India and other parts of the world, whether what type of data that can be accessed subject to the conditions of strategic applications, etc. I think this is a good program, good initiative from the government of India, and which is really implemented with all the dedication by IIT Tirupati, with the director Satyanarayana and our IIT Hub director of the Technology Innovation Hub, Dr. Roshan Srivastava. Because what is needed is technology pull, not technology push. We don't want technology just to be thrown out and for the publication, but technology pull, what is needed in the society, what is needed for the development in prime areas like agriculture, transportation, disaster management. These are the areas which are given focused by Dr. Roshan, and my hearty congratulations, and I wish him all the best of things in coming up and making great contribution from IIT Tirupati under his leadership. So any questions or something, they can be posted here, and Dr. Roshan will answer them at a separate time. Is it okay, Dr. Roshan?
Yes, sir. I'm okay, sir. Thank you. Thank you so much, sir, for your kind words. And you have been very supportive. And I think will be definitely taking your support to further take this hub forward.
Thank you. Thank you very much. Dr. Maria? Dr. Maria, you are there? Yeah. I'll take.
Yeah.
I just have our president has just conveyed to me that he may have he got a call from his group, and he may not be available, and he has authorized me, if you all permit, to say thanks for everyone here. And I'll just take a photograph of each here, and I think somebody may take, but let me have one photograph.
You can save the screen as well.
Yeah.
Saving the screen.
Yeah. Yeah. That's also an important thing. So because it's quickly, I can.
Fantastic.
So thank you, Dr. Maria. If you have any comments,
you.
etc., you can also say. Dr. Roshan, anything to mention? I think you're all available for the global community for any interaction, for any type of research, for any type of developmental issues. And we are here. The Earth space technology is meant for Earth, environment, and people. That is what is our goal. And let us make it a reality by applying our own contribution. ISPRS, the main focus is on this, and I'm really privileged to say that my working group, with the support of my young friend Lakshmi Thapa, without her, I cannot do anything here. So Lakshmi Thapa's support and our president, Laurent Polidori, we're all having a great involvement, and we wish to take forward the issues in a greatest spirit. Thank you very much for all of you.
Thank you. And bye.
Yeah. So I just wanted to, sorry, Dr. Brovelli, do you want to say something?
No, I want to say.
No, I want just to say thank you to everyone, and it was a pleasure for me. I hope that it was enough clear. I already answered the questions that you put in the chat. Okay, thank
Dr.
you,
Maria,
thank you.
Dr. Maria, I have many questions regarding transformer applications with remote sensing, because we're all applying for a natural NLP, and that is a great contribution, and I look forward to interact with you. That happens to be one of my current areas of focus research. Thank you very much for all this support.
Fantastic. Thank you, thank you.
Yeah, so I just wanted to say to those of you who are asking that if you can find the recorded version of this webinar or not, it's yes. So we will be uploading it within a week. So maybe by Friday, it should be available on our YouTube channel. Its name is like if you go to YouTube and type @ISPRS SC, you should be able to find it. Yeah, I just posted on the chat as well. Yeah, that's what I wanted to say. And there are a few questions. I think some of you were asking if you can ask questions or not, but I haven't seen any of those in the chat really. There is only one question in the Q&A for Dr. Brovelli, if that is fine to take now. Otherwise, I can email you later.
Schema, data, everything, and
you
now
can
people
decide.
with no
I think
background are
better.
taking.
Yeah, please.
It's just one question.
What are your thoughts regarding this? Oh, yes. No, it's true that we have studied the data standards, database, schema, but I have to say that all these things are useful all the same, because as a matter of fact, even in this case, using these foundation models, you need to have these schema in mind. Then I know that there is a lot to study. I have the same problem. So unfortunately, every day there is something emerging, and I'm a bit frustrated every day. But we have to reason in a different way. Probably we have to go toward a collective intelligence if we want to survive, because individually speaking is almost impossible, but we are also a community. And so why not to try to exploit in a good way what the other people are doing, instead of thinking that we need to do and to think everything. Let us use more our collective intelligence.
Yeah, here
Thank
is
you.
our president, Laurent Polidori. Please, Laurent, can you, Dr. Roshan is also there. One of the important things I want to mention is about the dashboard developed at the IIT Hub. And I want everyone to look into the dashboard by getting the appropriate, coordinates, etc., link, etc., from Dr. Roshan. And he's a specific technology dashboard on floods is one of the unique things. Please go for it. And Dr. Laurent, please, you have anything to say? Laurent, we are missing you. Yeah, are you not able to hear me, Laurent? Okay, Lakshmi, I think, what do you say?
So maybe he may still be occupied, like based on what you mentioned before, and that was his message to me as well. So maybe we can stop. We can go towards closing remarks. So from my side, I just want to thank you, all of you, and we are very grateful that you remember a student consortium for this kind of webinars, and it's very useful to students and young professionals like us. So thank you to our wonderful speakers, Dr. Brovelli and Dr. Srivastav. Both the presentations were very good, very contextual, and also the interaction, like the questions that are answered are very timely. So thank you once again. And also thank you to Dr. Murali Krishna. Thank you.
Thank you all. Dr. Lakshmi, I look forward for our Toronto meeting on entrepreneurship in remote sensing. Okay, thank you very much.
Sure.
Okay.
Thank
you, sir.
So,
thank you, everyone.
Bye, thank you.